Okay, this video is about Pythagorean identities. Okay, we're still doing trig, we're still dealing with unit circle, but we're going to put that together with what we know about Pythagorean theorem. Alright, so identities. These are going to be like little formulas you know, like Pythagorean theorem, a squared plus b squared equals c squared. We're going to add some trig to it, and then there'll be helpful little hints as we go along. Now, let's look at this picture for a moment. We've already talked about this circle on the the triangle on the unit circle. Here's our right triangle. That our x values are always cosine, y values are always the sine, and our radius is always a 1. So if we apply Pythagorean theorem to this triangle on our unit circle, we know that x squared plus y squared equals 1 squared, which is 1, right? Now if we put in the trig function for x, which is the cosine squared of theta, plus the sine squared of theta, there is a trig identity. That's what we call an identity. So cosine squared of theta plus the sine squared of theta has to always equal 1. All right, and that will be a helpful thing as we move along. Now, let's jump over to tangent and cotangent for just a moment. We said the sine, or the y is always the sine, so tangent can be written as the sine of theta over x is cosine of theta. All right, tangent is sine over cosine. Another identity you'll get comfortable with. The cotangent is the flip of that. So it's the cosine of theta over the sine of theta. Alright, so you will see these things, and you can replace tangent with this combination or this combination with cotangent, vice versa. They're little replacements that can help you simplify equations as we move along. Now, this is a major, this one right here, sine squared plus cosine squared, is a major identity you need to know. Now if we take this identity and play with it a little bit, let's say for instance we want to divide each term by cosine. Alright, so let's see what happens here. Cosine squared over cosine squared is just 1 plus sine squared over cosine squared. Now that's tangent squared. It's the same as sine over cosine, it just has the squared on it, so that would make this tangent squared. And then 1 over cosine squared. Well, you should remember that your reciprocal identities, that 1 over x is the same as secant, so this is really secant squared of theta, knowing your trig functions. Alright, so here's another trig identity you will use. So if you know the tangent of an angle, you can find the secant, basically is what's happening here. Without having to do triangles and all that good stuff, you can just use this equation. Now, let's go back to Pythagorean identity one more time. And this time let's divide through by the sine squared of theta. Alright, so what happens here? Well, you have cosine squared over sine squared. That, if you look down here to the left, that's cotangent, it just happens to be squared. So it's cotangent squared of theta plus sine squared over sine squared is a 1 equals 1 over the sine squared. Well, what's the reciprocal of sine? That's cosecant. And this one is squared because the sine was squared. So here's another identity you will use. Okay? Now the purpose of the identities is to kind of give us a shortcut to finding all these specific ratios. You don't have to draw the triangle and find all 6 ratios. You can, if you know these shortcuts, you can get there in 1 or 2 steps instead of having to go through all 6. So let me show you what I mean. Alright, before I jump in, look at this. I put the identities we just developed right here on the side so we can reference them as we need to. Alright, so the first example, find the cosine of theta if the sine of theta is 1/3 in quadrant 2. Now this little bit in quadrant 2 will come up at the very end, and we'll refer back to it in a moment. So I look at my question, sines and cosines. Well, which identity involves the sine and the cosine? Well, this first one right here. So I'm looking for cosine. So what I'm going to do, I'm just going to write this identity out. Alright, I'm looking for cosine. That's still my unknown. This says the sine squared. Well, the sine is 1/3. That's a plus sign, sorry. So I'm going to do 1/3 squared equals 1. Solve it. 1/3 squared is a plus sign. 1/9 equals 1. So I'm going to subtract 1/9 from both sides. So the cosine squared of theta equals 1 minus 1/9, which means I got to get a common denominator of 9, which gives me 8/9. All right, well that's cosine squared. I don't want cosine squared, I want cosine. So I got to take the square root of both parts. All right. 8, if you factor 8, that's 4 times 2. It's a perfect square, so it's 2 squared, so 2. Square root of 9 is a 3. Now, here's where the quadrant 2 comes in. If you think about your quadrant 2, right over here, what are your, if cosine is x values, right? Are your x values in this quadrant positive or negative? If you recall, your x values are always negative. That means since my answer is a cosine, it has to be negative. Okay? So the in quadrant little phrase is going to help you with the sign of your answer, basically. That's what it's going to do. Let's try another one. Look at this. Find the tangent if the secant is -9/4. And it's in quadrant 3. All right, so quadrant 3, we'll come back to that like I said. Tangent and secant. Which one deals with that? Well, the second identity right here. So I'm going to use that one. And plug in what I know. Tangent's my unknown. Secant is what I do know. So I have 1 plus the tangent squared of theta equals -9/4. But I have to square it because it's secant squared. Negative squared is always positive. All right. Now, I still need to solve for tangents. I'm going to subtract 1 from both sides. If I subtract 1, I have to get the common denominator 16. So that gives me, what, 65/16? That's tangent squared. But I want the square root of both sides so I can get just tangent. So that'd be the square root of 65 over square root of 16 is 4. Alright, so 65, factor it down, and you get 5 times 13. So that doesn't really help us. You can't reduce that. So this could be our answer. Now go back to quadrant 3. What's happening in quadrant 3? Down here. What is my tangent doing? Well, remember, tangent is y over x. Your x's over here are negative, and your y's are negative. So my tangent is positive, so that means my answer will be positive. So there's my solution. All right, for the whisk, I want you to do this using only these identities right here. Find the cotangent if the cosecant is 4/7, and it lies in quadrant 1. All right, hopefully that makes sense. Bring your questions to class, and we'll see you tomorrow.